A warm welcome to all of you. Thank you for attending the second edition of Kubernetes Community Days Bangalore. Shout out to the KCD Bangalore organizing team, especially Kevin, Aravind, and Prithvi, who really helped me a lot in putting together this topic. I hope you all have a wonderful session. So today's topic is Agile architecture and NFR non-functional requirements in a cloud-native design. A brief about me: I'm currently working as an assistant director, cloud practice at EY. Before that, I used to lead the Cloud Center of Excellence team, CCOE, at Accenture. I have around 10 plus years of IT experience and I've been working on public cloud since 2017. So what is the agenda for today? So this is a lightning talk around 10 to 15 minutes, and I will briefly touch on the context and background. What is architecture? Who or what are architects? Why does architecture matter? What are NFRs or non-functional requirements in architecture? And how does this link with cloud-native architectures? So let's start with some context. From physical machines to VMs, virtual machines to containers, we have really come a long way. Earlier, our focus was on on-prem systems. Then we went on a modernization journey to cloud-based workloads. And now the talk of the town is cloud-native architectures, as all of us know, Kubernetes and all of that Docker. But do you know what has stayed the same amidst all these technology innovations and new technologies and Kubernetes and containers and Docker and serverless? What has stayed the same? The business requirements. They have not changed. So the business necessarily does not care about Kubernetes or whether you are using Prometheus or whether you're using GitOps. They're only concerned about the business outcome. So while we will have new frameworks and new technologies, and they will obviously work as a catalyst in unlocking new opportunities, but the requirement for a well-architected workload that can help serve the business use case will always stay the same. It will never go. Sometimes we engineers are extremely influenced by new technologies and toolkits, like say, for example, any new shiny thing that is available in the market. But we should never undervalue or ignore the essence of everything, which is architecture. So the requirements for scalability, for fault-tolerant, performant workloads, these requirements are not new requirements. They have not come up because of this cloud-native revolution. These requirements was always there. And no matter what technology framework or paradigm we choose, we must always ensure we do not compromise on the basic architectural tenets. So that is very important, to focus on the basic architectural concepts, practices, and patterns. So I know most of us are very interested in learning new things. We want to go into this new shiny world of containers and container orchestration like Kubernetes, Docker, all of that. But we might only be able to give better value to our end users if we take a step back. To achieve some competency on cloud native architectures, we need to start here from architecture. So what is architecture? This is the first question that comes to our mind, right? What is architecture? How can we easily define architecture? So this is a very complicated definition of architecture, the fundamental organization of a system, its relationship to each other, but this is not consumable. This is a kind of a definition that is good for an IEEE definition, but it's not good to consume, right? So this is another definition which is a little bit better than that definition. So here Grady Booch defines architecture as a set of significant design decisions that shape a system, that shape the structure and behavior of a system, where significance is measured by cost of change. Again, this is a much better definition than IEEE one, but still not a good. This is a very good definition by Martin Fowler. He says architecture is a set of design decisions that must be made early. Okay, now coupled with that, if we get this definition by Matthew Parker also, who says architecture are decisions which are hard to reverse. So if I combine Martin Fowler and this guy's definition, then what is architecture? Architecture can then be defined as those design decisions that must be taken early on in the project lifecycle, because they are very hard to reverse later on, because reversing those decisions, reversing those architectural concepts or practices, there is a huge cost involved in terms of money, in terms of effort and all of that. So any decision that needs to be taken early on can be regarded as an architectural decision. So one of the example could be whether you go with a synchronous API based communication or you go with an asynchronous message bus based communication. So this can be treated as an architectural decision. This is a decision you need to take early on, because it might be very difficult to move from a synchronous to asynchronous or asynchronous to synchronous. There might be some cost involved with it in terms of effort, in terms of financial cost, resourcing, all of that. So now we understand what is architecture, right? Architecture is a set of decisions that needs to be taken early on because changing them later has an impact. But then what are architects? So this diagram is a very nice diagram. As you can see here, I am showing a cuboid. In the left, the person is seeing it as a circle. In the right, the person is seeing it as a rectangle. But the reality is more complex. So there are different perspectives, right? Some might think that this is like a circle, some might think this is a rectangle. But it's an architect's job to have a holistic overview of the system and say that no, this is neither a circle nor a rectangle, rather a cuboid. So an architect must have a holistic understanding of the system. It's very important. And there might be a different spectrum of views and viewpoints. And they need to take care of all of these different perspectives and then come up with a holistic view. So this is an architect's idea. And I really like this quote by Gregor Hopp, who says, an architect doesn't have to be the smartest person in the room. Instead, they make everyone else smarter. How? By having that holistic view of the system, helping the team take those architectural significant decisions that needs to be taken early on in the project and not later. But then why do we need architecture? This is another very important question. We know who are architects, we know what is architecture, but why? So this is a very nice quote. If you think good architecture is expensive, try bad architecture. So architecture matters. Why does architecture matter? Because without having a good architecture, you will lose the ability to respond to your business needs. It will become very hard for you to ship new features to support your customers. Why? So let us go with this graph, which is called design stamina hypothesis, again by Martin Fowler. So if you see this red arrow, this is an architecture, good design architecture graph, whereas this graph, which is the blue one, has no design. So this is the no design, this is a good design or good architecture. The blue curve is obviously a little ahead in the beginning, but in the next part you see the velocity decreases. Why? Because the system is not well architected. If you're changing something in the left, something is breaking in the right. Nothing is working. You cannot build new features. Something is breaking or it's not modular enough. It's not extensible enough because there is no good architecture involved. Whereas this red line you can consider as a good architecture. Maybe initially it is a little bit behind, but over time, it's because of its modular nature, because of its loosely coupled nature, you can add on good features without compromising. So this is the reason why we need good architecture. This is very important to understand. So what is agile architecture? So agile architecture is this pathway from immediate architecture to architectural intent, this roadmap. So from immediate architecture, which is my current architecture, to this architectural intent. And the good thing with agile architecture is both your immediate architecture and your architectural intent will evolve over time. So the roadmap is this journey from this immediate to the final goal, to the architectural intent. So obviously there will be differences, but they need to be aligned. So if your architectural intent is to have a microservice based architecture, then your immediate architecture can be a subset of it, but it should not be a monolith. So this is the concept of immediate architecture to architectural intent, which can be encapsulated as agile architecture. Not having a design based on strong architectural foundation will ultimately lead you to not being able to achieve business objectives. This is very important. So architecture is an extremely complicated topic. It has design, business strategy, human dynamics, IT environment, all of this. But to start the journey, we should focus on something which is quantifiable, and that is NFRs, or non-functional requirements. What are NFRs? Scalability, reliability, efficiency, security, maintainability, extensibility, testability, observability. These are just some of the NFRs. There are many more like performance, cost effectiveness. As a cloud or a software architect, our job is to ensure that our design is compliant with these NFRs. If my design is compliant with these NFRs, then it's automatically scalable, it's automatically reliable, then I automatically get a well-architected design. What is the most important thing that I need to focus on? That the essence of architecture has remained the same. We have gone from, say for example, from VMs to containers to container orchestration to serverless, but the architectural essence had not changed. So everything has stayed the same. The constraints and the attributes like scalability, reliability, performance, effectiveness, testability, these are not new things. These have stayed the course of time. They were important even in data center applications, and they are important even now, even sometimes more than they were before. So moving or migrating to the cloud does not mean that you do not need to think about scalability. You do not need to think about efficiency. You need to think about them even when you are in the cloud or you are in cloud native. The same constraints are present in cloud also, but the toolchain available is more robust and it's much more easier to consume. Even if you see, for example, at a high level, the AWS well-architected framework, so it has the same principles: reliability, security, operational excellence, cost optimization. These are all the same things. These are all the same non-functional requirements I was talking to you about. Now let's come to cloud native. So we all know what is cloud native. Cloud native is a new way of working with cloud to take the full power of the cloud. And it's based on a lot of principles and practices. These are some of the principles, right? Now, what if I say I take one of these principles, okay, and I try to prove to you that this is just an extension of the same non-functional requirements that we discussed. So we have already discussed NFRs. Now we are in cloud native principles. What if I can relate the two? So let's take an example. One of the key principles of cloud native architecture is immutability. What does that mean? That means an infrastructure should not be modified in place after deployment. Rather than modifying the infrastructure, I should have an automated way of creating another instance of that infrastructure or application. This means that I have an automated pipeline that can help me deploy that application again. So say, for example, my application goes down, I can leverage that same pipeline to deploy it again. So immutability or immutable architecture is actually leading the way to reliability. So reliability was the NFR I discussed earlier, whereas immutability is a cloud native principle. So they're kind of linked. That is the idea I'm trying to push here, that these are not new things. These are all linked. So in conclusion, what I want to explain here and what is the kind of message that I want to push forward is that non-functional requirements or the basic essence of architecture has not changed. Earlier we were, for example, from monolith to microservices to event-based systems, from virtual machines to containers to container orchestration to serverless. The tool chains have evolved. The flavors have evolved, but the basic tenets of cloud native architecture, the non-functional requirements like scalability, performance, they have not changed. If you can design something which respects the non-functional requirements of your business, then you will automatically get a well-architected system. Now that well-architected system can be implemented using cloud native toolchains. It can be implemented using containers. They are very compatible. That is true. So Kubernetes is obviously the way to move forward. But while playing around with these new tools, so today there is Kubernetes, tomorrow there might be something else. While playing around with these new tools, we should not lose our focus on the essence of architecture. We should not lose focus on the tenets of non-functional requirements. They are still as relevant as ever. We should always ensure that we respect the non-functional requirements of our architecture. We always should try to have good, well-architected systems that have an agile approach to architecture and that respects the non-functional requirements like scalability, performance, availability. So the cloud might be new, cloud native might be new, Kubernetes might be new. Today there is Kubernetes, tomorrow there might be something else. But if we as a whole, as an architectural community, as an IT community, keep our focus on the basic non-functional requirements and the basic architectural principles and tenets, we will end up with good, well-architected workloads. Thank you. I hope you had a great session and I hope you have a great KCD 2022 also. Take care.